Imagine we have an ordinary triangle. It can be any triangle with angles A, B and C, with sides lowercase a, b and c. We can start by drawing a line straight down from C, such that we create two right-angled triangles. We'll call the point where this line meets C big X, and the distance between A and big X will be little x. We can then work out what the distance will be between big X and B. You should be able to see that this distance will be equal to C minus X. Now that we've made two right-angled triangles, we can start to consider some trigonometry. We'll also define this line from C to X to have a length h. We can focus on triangle AXC first. We can use Pythagoras' theorem to write that x squared plus h squared equals b squared. We can then shift our focus to triangle CXB and say that c minus x squared plus h squared equals a squared. We can manipulate these equations as we would have done when we dealt with simultaneous equations. If we take equation 2 away from equation 1, we will get x squared minus c minus x squared. The h squareds would cancel out, and this would leave us with b squared minus a squared. With our new expression, we can expand the brackets to give us c squared minus 2xc plus x squared. Of course, remember we're taking this away, so each term will be times by minus 1. We can also cancel out the x squareds, since we've got an x squared and a minus x squared. We can now go back to our triangle. Let's look at triangle AXC again. If we take the cosine of angle A, what would it be equal to? Well, as cosine is the adjacent over the hypotenuse, and our adjacent is x and our hypotenuse is b, we can write that cosine of A equals x over b. Rearranging gives x equal to b times cos A. We can now take this and substitute it into our equation for x, to finally give this expression here. And finally we can rearrange this to get a squared equals b squared plus c squared minus 2bc cos A. This is the cosine rule.